See here. So topic name is OOPS Concepts. Listen, you already learned this in the second semester. So I explain fastly. Try to understand. Listen carefully here. So OOPS Concepts. So OOPS stands for Object Oriented Programming System. OOPS stands for Object Oriented Programming System. OOPS stands for Object Oriented Programming System. So actually, these OOPS concepts were introduced in the 1950s. In the late 1950s, these OOPS concepts were introduced. Okay, so these are introduced by MIT, one private university. MIT is one private university. So MIT stands for Massachusetts Institute of Technology. Massachusetts Institute of Technology. Massachusetts Institute of Technology. Okay, so Massachusetts Institute of Technology. Listen, MIT is the private university that introduced these OOPS concepts. So first OOPS concepts were introduced. Based on those OOPS concepts, object-oriented programming languages are developed. So based on the OOPS concepts, object-oriented programming languages are developed. So first object-oriented programming language is Simula language. The Simula language was introduced in the 1960s. So in the 1960s, Simula language was introduced. I will not record the class and I will not send the videos to anyone. Okay. Please don't depend on the videos. Use your brain, use your mind. Listen carefully. Okay. So Simula is the programming language that was introduced in the 1960s. So later in the 1980s, in the 1980s, C++ language was introduced. So this was the first famous object-oriented programming language. So based on the Simula language and C language, the C++ language was developed in the 1980s. You already know Barney Strostrup. Barney Strostrup developed this C++ and he introduced this language. Barney Strostrup. Pronounce it as Barney Strostrup. So Barney Strostrup developed this C++ language, introduced this in the 1980s. So this is the object-oriented programming language. In the previous class, I told that if any language that supports to four concepts, that language is called object-oriented programming language. Okay. So what are those four concepts? Encapsulation, abstraction, inheritance, polymorphism. Okay, so encapsulation, abstraction, inheritance, and polymorphism. These are called OOPS concepts. If any language that supports to these four concepts, those languages are called object-oriented programming languages. Okay, so if any language that supports to these four concepts, encapsulation, abstraction, inheritance, and polymorphism, that language is called object-oriented programming language. See here. So for all these four concepts, two common concepts are there. Those are class and object. So class and object are the two common concepts of encapsulation, abstraction, inheritance, polymorphism. To implement these four concepts, these two common concepts are required, class and object. So what is the topic name here? OOPS concepts. So OOPS stands for Object Oriented Programming System. So these OOPS concepts were introduced in the 1950s. So MIT is the private university. MIT stands for Massachusetts Institute of Technology. So this university introduced object-oriented programming system concepts, OOPS concepts. Based on the OOPS concepts, languages were developed like C++, Java, Python, similar language. Such type of language are developed. So if any language that supports to four concepts like encapsulation, abstraction, inheritance, and polymorphism, if any language that supports to these four concepts, those are called object-oriented programming languages. For all these four concepts, two common concepts are there, class and object. So these are called OOPS concepts. These are called OOPS concepts. These concepts are called OOPS concepts. Okay, the name itself indicates object oriented, means everything revolves around the object. Object oriented means everything revolves around the object. Then what is the general meaning of object? Listen carefully, pay attention and listen carefully. What is the general meaning of object? Object means anything. General meaning, I'm explaining general meaning, okay, not the technical meaning. So anything which is physically existed, anything which is physically existed is called object. Anything which is physically existed is called object. Okay, for example, chair is physically existed, bench physically existed, fan physically existed, AC physically existed, cooler physically existed. So anything physically existed is called object. Okay, that may be your phone, okay, or bottle, okay, or table or chair. Anything physically existed is called object. And anything which is not physically existed is not called an object. Anything which is not physically existed is not called an object. For example, thoughts are not physically existed. Thoughts are not physically existed. Imaginations are not physically existed. Okay, increase your volume. Okay, if you are getting low voice, increase your volume. So anything which is physically existed is called object. Anything which is not physically existed is not called an object. For example, thoughts are not physically existed. Imaginations, concepts, plants, these are not physically existed. So plants, concepts, thoughts, imaginations, these are not physically existed. Okay, so those are not called objects. Anything which is physically existed is called object. Okay, like your phone is physically existed. Okay, my keyboard, mouse, monitor physically existed. Okay, chair, table physically existed, marker physically existed, duster physically existed. Physically existed things are called objects. Okay, so now you know the meaning of object. So for any object, some properties will be there. Listen, for any object, some properties will be there. Some properties will be there, and that can be used to perform particular actions. Any object that can have some properties and that can be used to perform particular actions. For example, I'm taking marker as the example. So marker is physically existed, marker is the object. Okay, so what are the properties of the marker? See, which what is the color of the marker? Color is the property. So red marker, blue marker, black marker, like that. So color is the property. Okay, which company's marker? So that marker is which company's marker? So Reynolds company marker, Camlin company marker. So what is the price of it? What is the price of it? Okay, 30 rupees, 40 rupees, 50 rupees, like this. So color is the property. Okay, company name is the property, price is the property. These are called properties. These are called properties. And why we are using this marker? for writing on board, for writing on whiteboard. So writing is the action. Writing is the action. Okay, so like this, for any object, some properties will be there, as well as that can be used to perform particular actions. See, just a minute. See here. So for marker, what are the properties? Properties are color. What is the color of the marker? Which company's marker? What is the price of it? Okay, those are what properties. And why we are using it? For writing on board. Okay, so I'm giving one more example to understand it. I'm giving one more example. Listen. For example, I'm taking smartphone. So smartphone is physically existed. Okay, you are using smartphone. With the help of smartphone, you are attending the class, or you are using laptop or computer to attend this session. That is physically existed. Okay, so I'm taking example as smartphone. For any smartphone, some common properties are there. What are those? What is the color of it? Okay, that may be black color or gold color or white color, okay, or blue color. So color is a property. Color is the property of the smartphone. What is the price of it? What is the price of, sorry, smartphone? What is the color of the smartphone? What is the price of the smartphone? Okay, what is the cost of it? Okay, and what is the model of it, and which company's smartphone? So company names like Samsung, okay, Apple, Oppo, Vivo, company name, which model, model number. Okay, all these are what? These are the properties. So these are called properties. So what are the methods? See, what are the actions? Which actions we can perform by using smartphone? Okay, you can give the calls and you can attempt the calls. Okay, so you can give the calls and you can receive the calls. You can give the calls and you can receive the calls. Okay, so for calling, we are using smartphone. Okay, for video calling, we are using smartphone. So video calling is one action we are performing by using smartphone. Calling is one action we are performing by using smartphone. Okay, browsing is one action I'm performing by using smartphone. Enjoying music is one action we're performing by using smartphone. Okay, watching movies. So like this, we can do many actions by using this smartphone. So here the point to understand here is, you, for any object, for any object, some properties will be there, as well as that can be used to perform particular actions. Okay, just a minute. See here. So for any object, some properties will be there, as well as that can be used to perform particular actions. Just now I have given two examples. So one is marker and another one is smartphone. Okay, so see here. So to create such type of objects, I want to create the objects like this. So these properties, these are the actions. To perform the actions, we define methods. To perform the actions in C++, we define the methods. Each method we are defining to perform particular actions. So those actions I'm calling as methods. So now in this example here, in the marker example, this color, company name, price, these are called properties. These are called properties. This writing is called method. This one is called method. Okay, in this example, in the smartphone example, here color, price, model. Okay, all these are what? These are the properties. These are the properties. Okay, so calling, video calling, okay, browsing. What are these? These are the methods. Okay, so to perform the actions, we define the methods in the C++. Okay, now see about what are the OOPS concepts. So this is the general terminology. Remember this one. So object means anything which is physically existed. Anything which is physically existed is called object. So for any object, some properties will be there, as well as that can be used to perform particular actions. So marker has properties like color of the marker, company name, price of it, okay, weight of the marker. These are the properties. Why we are using marker? For writing on board. So writing is the method. For the smartphone, color, price, model, company, all these are the properties. Why we are using it? For calling, video calling, browsing, for enjoying the music, for watching movies, we are using it. These are the methods. So remember this one. For any object, some properties will be there, and that can be used to perform particular actions. This is a general concept. Now see what is class. In the OOPS concepts, what are the OOPS concepts? Class, object, encapsulation, abstraction, inheritance, and polymorphism. These are called OOPS concepts. Okay. So among this, first one is class. What is class? Observe here. So actually, class means class is a user defined data type. What is class? Class is a user defined data type. We are defining our own data type here. You are defining class means you are defining your own data type. You already know the data types, like int is the data type, float is the data type, char is the data type. These are called primitive data types. Like primitive data types, I want to define my own data type student. I want to define my own data type customer. Okay, I want to define my own data type product. So like that, if you want to define our own data types, we use this concept class. In the C language, you learn the structure concept. Structure is the user defined data type. Union is a user defined data type. Enumeration is a user defined data type. Like that, this class is also user defined data type. So class is the user defined data type, and it is a plan. It is a plan. Class is a plan to create the object. Class is a plan to create the object. So to create the objects, first we are making a plan. That plan is nothing but class. For example, see here, let me explain clearly. See, for example, to construct a home, before going to construct the house, first we take the plan from the engineer. First we take the plan from the engineer. So constructed home is the object physically existed. Constructed house is the object physically existed. So to construct the house, first you are taking plan from the engineer. Okay, that plan is the logical one. Constructed home is the physical one. Okay, so like that, I want to create the objects now. So I want to create student objects. So student is physically existed. Okay, Raju student physically existed. Ramu student physically existed. Okay, see here. So I want to create student objects like student rule number, student name. So first student, so to hold rule number, I'm taking this variable and name, rule number and name. Okay, so now this one is the S1 object. This one is the S1 object. So like this, I want to create some more student objects. Okay, so this is student 2, student 3, student 4. So like that, n number of students data I want to maintain. So I want to create student, I want to maintain student objects like this. So first student rule number is 10. His name is Sai. Okay, next second student. Second student rule number is 20. His name is Ravi. Third student rule number is 30. His name is Srinu. Okay, next fourth student rule number is 40. Okay, his name is Kiran. So like this, I want to create 4 objects here. So this is S1 object, this is S2 object, this is S3 object, and this one is the S4 object. S4 object. So like this, I want to create student objects. So for any student, some common properties are there. For any student, some common properties are there. What are those? Student rule number, student name. So rule number name I want to maintain. So rule number name are the properties. Okay, I want to read student details. So reading is action. I want to print student details. Show is action. Printing is action. Reading is action. So to perform the actions, I'm defining the methods here. So this is the plan I'm making to create the student objects. So this plan is nothing but class. This plan is called class. So I'm giving class name as student. That's it. So for any student, that may be Sair or Ravi or Sinu or Kiran, for any student, common properties are rule number, name, and methods are read and show. I will give another example to understand more clearly. Listen carefully. For example, one bank wants to maintain customer details. One bank wants to maintain customer details. So that bank wants to maintain customer details like customer account number, okay, customer name, and his account balance. Okay, so this is customer one. So here they want to maintain customer account number, okay, then customer name, okay, and customer account balance. So this is customer one object. Okay, so like that, I want to create many objects. That bank is maintaining many customers. Okay, so lakhs of customers are there. So they want to maintain customer objects like this: customer one, customer two, customer three, customer four, and so on. Okay, so to create this type of customer objects, first we have to make a plan. What are the common properties for any account holder? What are the common properties? Account number, and he has a name. Account holder has a name. He is maintaining balance. What are these? These are the properties. These are called properties. Okay, so any customer is performing some transactions. So bank customer performs some transactions. What are those transactions? What are those transactions? Like he withdraw the money, withdrawing the money. So withdrawing is one action. Depositing the money is one action. Okay, transferring the funds, fund transfer is one action. From one account to another, I want to transfer the money. So for that, I'm defining the method fund transfer. So these are the actions performed by the bank customer. So we are placing several properties here: account number, name, balance. These are called properties. These are called properties. So properties can be also called as fields. Fields. These fields can be also called as attributes, or you can also call them as instance variables. You can also call them as instance variables, or you can also call them as member variables. Member variables. This is the terminology you have to know. This is the terminology. Okay, so properties can be also called as fields, or you can also call them as attributes or instance variables or member variables. So here account number, name, balance are called properties. Okay, so these are called methods: withdraw, deposit, fund transfer. These are called methods. So methods can be also called as uh, member functions. Methods can be also called as member functions. This can be also called as member functions. So combinedly, properties and methods, you can say them as members. So these are called members. So these are the members. This is a terminology. So here I'm giving this class name as customer. So to create such type of customer objects, customer one, customer two, customer three, so like that physically I want to maintain customer details, customer objects. So for that I am making this plan. Okay, so here this is the plan. This class customer is the plan we are creating. Okay, we are making this plan to create such type of customer objects physically. Okay, Now session is in ending. Okay, so that's why I'm not joining them. Okay, now session is in ending, that's why I'm not joining them. Soumya. Okay, now session is in ending, so that's why I'm not joining them. Okay, see, so here what is class means it is a plan to create the object. Just like before going to construct the house, we are taking the plan from engineer. Just like that, to create the objects, we are making a plan. That plan is nothing but class. So what a class contains? What a class contains? So class contains properties and methods. In the class, we are defining some properties and methods. We are defining some properties and methods. So class contains properties and methods, and it is logical container. This is the logical container, means it is not existed physically. This is logical one. This is not physical one. Okay, so this is about class. So just now I explained that object means this object is the copy of a class. Object is a copy of a class. Object is the copy of a class, or you can say this as the instance of a class. You can say this as the instance of a class. Here instance means example. Instance means what? Example. Instance means example. So here class means you can say that as a classification. From the classification word only they have taken this class word. Class means classification, or you can say this as group, or you can say this as category. So class means that is nothing but group or category. So an instance of a class, a copy of a class is called object. I will give some simple examples to understand it. Okay, listen. For example, flower. Flower is a concept. Flower is not physically existed. There is a concept. Okay, rose flower physically existed, object. Lily flower physically existed, object. Okay, jasmine flower physically existed, lotus flower physically existed. So physically existed or object. So flower is the concept. That is one category, group, classification. So flower is the logical one, not physically existed. That's one group. So rose is example of the group flower. Lily is example of the group flower. So here rose, lily, jasmine, lotus, these are the objects physically existed. Flower is the concept. This is logical one. So like that, bike is the concept. Bike is the concept. Okay. Splendor bike physically existed. Okay. Activa bike physically existed, like this. Okay. Pulsar bike physically existed. So physically existed are called objects. So bike is the concept that is not physically existed. So Splendor, Activa, Pulsar, these are examples of bike. Okay. I hope you understood. So object means it is the physical copy of the class, of the category. Okay, just now I explained that here customer 1, customer 2, customer 3, customer 4, these are the objects physically existed. Raju customer, Kiran customer physically existed. This class is nothing but plan, logical one. Okay, so this is about class and object. Okay, so what is encapsulation? Encapsulation means, the general meaning of encapsulation is the action of placing something is the general meaning. Encapsulation means the action of placing something. So the action of what we are placing, we are placing several properties. The action of placing properties and methods in a container, in a class. That container I'm calling as a class. The properties and methods in a class is called encapsulation. So in the general meaning of encapsulation is the action of placing something. Observe here. See, the action of placing something. So what is that something? Properties and methods. So we are defining these properties and methods in one container. These are the properties. Account number, name, balance, these are the properties. Okay, account number, name, balance, these are the properties. Okay, so withdraw, deposit, fund transfer, these are called methods. So we are defining several properties and methods in one container. I'm calling container as the class. So we are defining class means that is nothing but encapsulation, you can say combining. So we are placing several properties and methods in one container, that is called encapsulation. This is about encapsulation. Now I'm stopping the session here. I'm stopping the session. So remaining OOPS concepts I explain in the next session. Okay. So regarding today's session, if you have any doubts, you can ask. Any doubts? Okay. Did you understand today's class? Please give the response. All of you give the response. Did you understand today's class? So very general concept. So what is object? What is class? So class is the logical one. Object is the physical one. That's it. Single sentence. Class means logical one. Object means physical one. That's it. Okay. I'm stopping the session. Thanks to all. Meet you tomorrow.